By now, we're all familiar with a fraction which has both a numerator and a denominator, such as a plus b over c plus d. But in this section, we may also find what's called a complex fraction. And a complex fraction could have multiple numerators. For example, we might have something like a over 2 plus b over 2, and then all of that could be divided by, for example, c over 2 plus d over 2. So it's a complex fraction in that it's a fraction within a fraction. Now we can take advantage of a property of complex fractions where if every term is being divided by the same constant, then we can actually cancel all those common denominators, and the fraction that we had will now be just the result of all those numerators put together into one fraction, like this. So what we're looking for is a common denominator for every term. Let's try it with some numbers first, like for example 2 minus 1/3 over 4 plus 11/3. Our goal will be to build the 2 and the 4 to higher terms so that they can have denominators of 3 as well. Okay, so to get the 2 to have a denominator of 3, we need to multiply it by a fraction of our choice. And we'll do the same thing with the 4. The right choice to make here would be 3 over 3 and 3 over 3. In fraction multiplication, the 2 is assumed to be a numerator because it's alone. So we're going to want to multiply the 3 times the 2, and we could put the 2 over 1. And do the same thing with the 4. Alright, so we'll have, looks like 6 over 3 minus 1 over 3, all divided by 12 over 3 plus 11 over 3. As you can see, they all now have the same denominators. And so what we're going to want to do then is just cancel all the denominators. This will leave us with 6 minus 1 over 12 plus 11, which is 5 over 23. All right, you can check your work with a calculator and simply type something like this into an online calculator, such as symbolab.com or desmos.com. And we want to see that the value we get from this fraction matches the value of our final result. All right, let's try it now. So you want to bring up a fraction here and do 2 minus 1/3 over 4 plus 11/3. So Symbolab will give you just a decimal approximation of that. And it even simplifies it for you. So 5/23 is correct. Let's say we've got something involving variables though. For example, let's say we've got 1 plus 1 over x divided by 1 minus 1 over x squared. The same principles apply. We want to get a common denominator for all the terms. So what we're going to want to do is build some of them to higher terms. We got to figure out what the least common multiple will be, though. So you check out the denominators. Now these ones are alone, so they don't have a denominator other than just 1. Now we can rewrite it as 1 over 1 plus 1 over x divided by 1 over 1 minus 1 over x squared. And we can see that the largest denominator here will be the x squared. So we're going to want to build all the others to higher terms. Now, how do we do that? Well, let's introduce a fraction to each of the terms. And we don't actually have to change this lower right term here. It's already got the least common multiple of x squared. All right, so what do we multiply by in each case? Well, we need the denominators to become x squareds. So I'm going to multiply by x squared over x squared here. And I'm going to multiply by x over x here. As you can see, the denominator, once we multiply, will become x squared, which is what we need. And here, I chose x so that when we multiply these guys, we'll get x times x, which is x squared. And this one will have to be multiplied by x squared over x squared. Okay, so let's do that. We'll get x squared over x squared plus x over x squared, all divided by x squared over x squared minus 1 over x squared. Notice that they all have that common denominator now, which is what we wanted. Okay, so what we can do now is we can cancel all the denominators and arrive at a new expression, x squared plus x over x squared minus 1. And now it's not a complex fraction anymore. It's much easier to deal with. We'll want to now use techniques from the past of just factoring the numerator and denominator to see if we can simplify it any farther. So I'll pull out the common x on top. We'll get this. This is a difference of perfect squares, so we'll do x plus 1, x minus 1 on bottom. These will cancel, and we'll get it down to x over x minus 1. And that's our simplified result.